let's talk a little bit about actuator control with CAN, because this is also was a big part of this project, and also is a big part of this example that I'm going over in this input-output framework. All right, so as I mentioned previously, we have this Simulink outbound message or topic that we are writing from the Simulink model, and it's being grabbed by the Simulink control module, and does all of the low-level stuff and handling and whatever using parameters, and applies correct settings and configurations that we can cover later. But at the end of the day, is publishing this actuator output servo, or just SV, UORP topic, which is essentially a way to move the data and make it available for the UAVCAN driver. I had to modify the UAVCAN driver, essentially upgrade that to support just regular servos and regular one-shot PWM that are using just PWM protocol for all of the, I guess, communications, but it's done through CAN-enabled expansion boards. So you're talking over CAN language or protocol with your external hardware. In this case, there is like a PWM/CAN expansion board, which that board talks with the actuators using PWM, but we talk with the board using CAN. That's like a very important distinction. So this upgrade or whatever was to support that, because out of the box PX4 of the version 1.12.3 was configured to only work with CAN enables ESCs, electric speed controllers. So that's direct CAN to the ESC, and there's no expansion of any kind of for whatever board that we want to use. So this is a very special case, but just introducing this again. Similarly, how the debug array was used, I'm using the built-in actuator outputs and simply creating additional instance of that actuator output servos. Don't confuse, I call it servos now, but technically I'm using the same exact output for, and internally we can configure if those are used for talking with the servo or an electric speed controller. This was mostly related to that it's just PWM. It's straight PWM. We don't have anything else. And later in the future, I can add separate support for ESCs, or at least that's what I was considering. But the more recent firmware does that anyway, so there's no reason to do that. All right, so again, this is all happening on the board, PXOC board, inside of the firmware. And we are just sending CAN signals to the expansion board. And the way it looks like, if you wire it all up, I mean, it's, again, wiring CAN is quite a pleasure. It's very convenient, quick, and simple, as long as nothing breaks in the process. You have your PXOC cube. You have to use CAN 1 because it does all of that automatic CAN node thing configuration that just works nicer. And obviously there are parameters associated with it, which we'll cover later. Basically, CAN 1 plugged in here or anywhere, really. This is just a plain, the CAN expansion, or these CAN pin-out expansion boards / whatever you. This is not PWM expansion, sorry. This is just like how to connect multiple CAN wires together, right? So these are just directly wired together. This is not doing anything fancy. You could have directly plugged in this and into this board and into this one without any difference. But anyway, so this is how a standard CAN works, so I'm just not going to be explaining that too much. But the key part is that we need to configure everything internally in the PX4 using its own parameters. So there is a param module. We configure parameters such that Simulink control module is correctly writing and interpreting these commands, high-level commands from the Simulink module, such that being properly interpreted by this PWM expansion board. These are two separate boards, by the way. You can have multiple of those, but here this is the wiring diagram specifically for the tilt wing. I only use two boards, just call them 11 and 12, because this is also the same ID that I use for CAN node. Can be anything. This is just, again, your own convenience, my own convenience. The key part is that we are using, again, PWM on this end. So these 5 to 9 pins, 5 to 9, they're just plain PWM output pins. This chip and the code there, obviously it interprets everything, and you can just connect any servo or any ESC that's using one shot or just plain PWM and drive that. These are for other purposes. Let's just not talk about them. So we're only using these. The important part, this is basically just a quick shortcut, is that in your, if you're using this framework, again, if you're using Simulink outbound on the input-output framework that I'm providing, these 16 actuator commands, they're ordered sequentially. So actuator number 1 is number 1. Actuator number 2 is number 2. I mean, this is as simple as that. That is not going to get flipped. It can be ESC or it can be servo. That's a separate issue that is handled internally to this module, and we can use parameters to configure. But the ordering is all consistent. Whatever's the first, it's going to be the first everywhere. Or, I mean, there could be some confusion maybe in the code, because MATLAB uses 1-based indexing, starts with index 1, and C++ it starts from 0. But that's if you look directly at the code and the PX4. Here I'm starting everything from 1, just for, again, for convenience. All right. So, and this on the left, the very leftmost column, this is an example of how you would, for example, write outputs of your Simulink model. You have 16 outputs. You don't need to assign all of them, obviously. I mean, you can zero out the rest or just ignore them. But you start from the first one and use, I mean, set some values, whatever you want. But I mean, they can be static. They can be changing all the time. But basically, first output is the first entry in this vector. Set the value for that. For the CAN sort of based convention for this board, all of the servo outputs, which that's what these are called, or basically direct PWM outputs, they are going to start from 50. So pin number and you have to set these manually in the firmware of this board. You can use UAVCAN or DroneCAN debug tool or anything like that. You can configure that. That's going to be, again, probably a separate video. I provide just files for that. It's quite simple. You just have to say, okay, my first output on the pin 5, so these are pin numbers. See, they repeat on both. So pin number 5 is interpreted as the output 51. Because this is channel 1 on the through the CAN language protocol. So you have to write inside of the CAN, which again, you don't see those things. It's just like, know that the first output of the Simulink model is sent as the actuator number 51 over CAN, such that, and it's already, this board has to be configured to say that, hey, physical pin number 5 corresponds to 51, to output 51 on the CAN, I guess, network in this case. Same thing for everything else. So these pins, they're not really, this number can be confusing, but basically these are, I try to match them. So they start from 50. So 2, 52, 53, and so on, 7. You can skip some, you don't need to use all of them. Whoops. Same thing here. I don't use actuator 8 and 9 for anything on this vehicle, but I use it on the other one, so I'm just skipping those to keep code consistent. I'm just going directly to output number 10. So there's output number 10 of my Simulink model. That is being assigned again to ID 60 over CAN network. and that is mapped by this board to be physical pin number 5. And it just keeps on going like that. So this part is fairly custom. Again, you can do whatever you want, but you want to start with 50, because everything below that is treated as the ESC outputs, and you may run into some problems when configuring these boards. So just start with 50.